let's start with question 1. So George is taking a bunch of tests, and we want to find what he got on his third test. So first, let's just start by, let's let x be his grade on the first test. So the problem states that on his second test, he missed half as many points as on his first test. So each test is out of 100 points. So that means that to find what he got on the second test, we would have to divide, not divide yet, but first subtract his grade on the first test from 100 and divide that by 2 to get how many he gets wrong. And then we have to add x to it. So if we simplify this and we make this into one whole fraction, we will find that plus 2x divided by 2, we'll find that his second test score can be represented by 100 plus x divided by 2. And then on his third test, it says that it was 4 points higher than the second test. So we just add 4 to this. And this simplifies to 108 plus x divided by 2. Now the average of all 3 tests is 88. So that means that when we add all of his tests together, all of his test scores together, they will add up to be 88 times 3. Now we can actually solve this equation and solve for x. So 88 times 3 is equal to 264. And this side of the equation simplifies to 208 plus 4x. Okay, so if we divide 2 from this fraction, then we get 104 plus 2x is equal to 264. So if we subtract each side by 104 and then divide it by 2, then we'll find that x is equal to 80. So the problem's asking for his grade on the third test. So we just plug that back into this, plug x back into this equation, and we'll find that 108 plus 80 divided by 2 is 94. And that is your answer. Question 2, we are given some rectangles. We're given 2 rectangles, and we know that the inner rectangle, the bigger rectangle area is twice of the smaller rectangle. So we can write this out as an equation. We know that 400 times 300 times 2, that's the area of the outer rectangle. And we can also represent the area of the outer rectangle by doing 300 plus w, plus 2w, since the length of this width is just 300 plus 2w, and then this side is just equal to 400 plus 2w. So, if we expand this out, we get 240,000 is equal to 120,000 plus 1,400 w plus 4w squared. So let's just subtract. Let's subtract each side by this big number, and we'll get 0 is equal to 4w squared plus 1,400w plus, minus 120,000. Now, we'll use the quadratic formula to solve for w. That is, wait, not yet. Oh no. Actually, let's just first divide. Let's divide this equation by 4. That will make things easier. We'll get w squared plus 350w minus 30,000. Now we can plug that into the quadratic formula, and we'll get negative 350 plus or minus square root of negative 350 squared minus 4 times negative 30,000 divided by 2. And this, you can use your calculator to make things easier, but we will get two answers: negative 421.22 or 71.22. So either way, you only have one answer here, which is 71.22, and that's because this w cannot be negative. You cannot have a negative width. So our answer is 71.22.
I have a question.
Yeah.
So, technically, couldn't you just guess and check this question?
Well, I think that would be a bit hard, seeing as the answer is a decimal. So, if the
I thought. Sorry.
What?
But I thought when it meant approximately, it would mean like an integer value.
Oh, yeah.
So I got 71, not 71.22.
Yeah. This question was originally a multiple choice question, so it depends on the context of your exam, I guess. But you could guess and check, I guess.
Okay, thank you.
All right, let's speed through this. Question 3, we simplify this big equation. So this is just pure algebra. First, we want to get rid of this. We don't want that thing there. So we're gonna multiply this whole fraction by 8 plus square root of 3. 8 plus 3 square root 7. So that we'll get 2 times 8 plus 3 root 7, which is just 16 plus 6 square root 7. And then this bottom, this denominator, that's just in the form of a squared minus b squared. So basically 8 squared minus 3 root 7 squared. And that is just equal to 64 minus 63, which is equal to 1. So we can just get rid of the denominator now. And we're left with 16 plus 6 square root 7. So now let's simplify this thing. 63 is divided by 9. Well, it's divisible by 9, so we can pull out 3 from there. And we'll get 3 times 2 times 7 times root 7 plus 16 plus 6 root 7. Now we can add these two together to get 12 root 7. And then this entire thing is divisible by 4. We can take 4 out of both of these. And we're left with 4 times 4 plus 3 root 7. Now we can move this 4 out to get 2 times 4 plus 3 root 7. And that is your answer. So now we're given a hexagon, a regular hexagon. Regular hexagon just means that all the sides are the same length. So it says that the hexagon's vertices lie on a circle with a radius of 6 centimeters. I forgot to draw the circle, but oh wow. It looks something like this. Since the radius is 6, that means that this thingy is 6. And we know that for a regular hexagon, all of these interior angles is just 120 degrees. And this line right here this line is a bisector, so that means that it will divide these two into 2 equal angles of 60. So this is also 60. That means that this is 60. So basically, a regular hexagon is composed of 6 equilateral triangles. And if we find the area of one equilateral triangle, then we can find the area of the entire hexagon. So the formula for the area of an equilateral triangle is root 3 divided by 4 times s squared. S is your side. So we know that all the sides of this, all of these equilateral triangle is 6. And there are 6 triangles making up the hexagon. So this is our area, and that simplifies to 54 root 3. The question 5 is very similar, and like the last problem, the area of a regular hexagon is basically s squared, 6 times 3 root of 3 divided by 4 times s squared.